Hello everybody, welcome to Soil Mechanics online course. Today I'm gonna talk about soil classification. You may ask, why should we classify soils? Well, the reason is pretty simple. Classification of soils into groups with similar engineering properties such as compressibility, strength, and hydraulic conductivity helps engineer in evaluation of their important properties for engineering use. There are several classification systems available. Each was devised for a specific use. For example, the American Association of State Highway and Transportation Officials, or called AASHTO, developed one scheme that classifies soils according to their usefulness in roads and highway. And the Unified Soil Classification System, short for USCS, was originally developed for use in airfield construction, but was later modified for general use. In this course, we only covered the unified system. The unified system separates soil into two categories. One category is coarse-grained soil, and the other is fine-grained soils. If more than 50% of soil particles are larger than 75 micrometers, this soil is coarse-grained soil. If more than 50% of soil particles are finer than 75 micrometers, this soil is fine-grained soil. Coarse-grained soils are subdivided into gravel and sand, and fine-grained soils are divided into silt and clay. Each soil type, gravel, sand, silt, and clay, is identified by particle size, as presented in the figure. As you can see that, this system do not separate silt and clay based on size. They are classified using the Plasticity Chart. We will talk about it later. The USCS uses symbols for particle size groups. These symbols and their representation are G for gravel, S for sand, M for silt, and C for clay. These are combined with other symbols like W, P, H, and L. W and P express gradation characteristics. W for well-graded and P for poorly graded. H and L show plasticity characteristics. H for high and L for low. And a symbol O indicates the presence of organic matter. If you see GW, it means well-graded gravel, and SP means a poorly graded sand. The flow chart presented in this figure provides detailed steps for classifying a coarse-grained soil according to the USCS. Before going into the flow chart for classifying fine-grained soil, we gotta know the plasticity chart first. In this plasticity chart, ordinate indicates plasticity index and abscissor indicates liquid limit. It is found that clay, silt, and organic soils lies in distinct regions of the graph. A line defined by the equation Pi equals to 0.73 times LL minus 20 is called the A line. It draws the boundary between clays and silts and organic soils. Above A line are clays, and below A line are silts and organic soils. Another line, called the U line, defines the upper limit of the correction between plasticity index and liquid limit. Detailed procedures for classifying fine-grained soil are shown in this figure. You won't have any problems by using these two charts since they are very straightforward. A homework problem is left for you. For the fines of the soil A, it is known that the liquid limit equals to 58 and plastic limit equals to 36. And for the fines of soil B, given that liquid limit is equals to 60 and plastic limit equals to 28. you are required to classify the soils based on USCS. Enjoyed it and good luck. That is all for today. See you next time.